Okay.
Okay, my name is Steve Sheik. This is
I'm George Grados.
this is our laser surgical device. We've been working on. It's a prototype for a machine that will do both laser surgery and laser therapy. As you know, laser therapy, if there's people who have wounds that aren't healing at all, such as diabetics or abscesses, laser therapy will start the healing process. And also laser therapy is used a lot in athletes who get hurt on the field, so they can get them back out on the field as soon as possible. And this machine will also do laser surgery. A laser surgical device will cut and cauterize at the same time, so it becomes virtually bloodless surgery, which is invaluable in patients who have bleeding problems or are on blood thinners. So instead of weaning the patients off the blood thinners to do the surgery, the surgeon can just go right ahead and do the surgery that's necessary. Quite often it can be life-saving. This is the machine we have here. This laser here is the largest laser device that's out on the market right now, or will be once it's fully implemented. And right now we're putting our laser into this calorimeter because we need to be able to measure this, the output of this laser without hurting anybody. So we send the laser into the calorimeter. We have the driver, which is the best driver there is on the market. In the end, this device will be operated from a foot switch. The one on the right will be for surgery. The one on the left will be for therapy. This is the SB Rio over here, which is the device that is the FPGA device that will operate the whole system. And from there, we will move into the HMI, which I'm going to let George talk about.
So the HMI is basically a human-machine interface. It's a touch-screen device, which through the use of LabVIEW, we're using a state machine program, which is designed to show a few menus on the HMI. And from there, we could use the various buttons and set parameters to operate the entire machine. So I'm just going to run a quick example. This is our layout. Just run it. I will set the pulse width. And from there you can see we have an output of about 6 watts, 5 to 6 watts. You could always adjust it to make it higher or lower. And if you turn over here to the HMI itself, we have our basic setup screen, with a few buttons already set. Quick menu tabs, which haven't been implemented, but we have set them to switch back and forth. And lastly, we have our thermistor, or temperature sensor actually, which if I just apply a few pressure, the temperature slowly adjusts up and decreases when I let go.
And when the temperature goes up high enough, the fan starts. And when the temperature drops back to where it's supposed to be, the fan will turn itself off.
So as of now, this is the only thing we have in terms of progress. We still have a lot more work to cover in terms of implementing the other devices, such as the foot pedal. And from there, in terms of future plans, we plan to use a much higher laser diode driver. And lastly, we plan to implement and install all this into our metal casing over here.
The HMI will be located on the front of this device, and the surgeon or the practitioner will be able to operate this whole thing through a touchscreen right on the front.
Okay.